Okay friends, welcome to Login Science. In today's video, we are going to solve question 2 from DBE, and this question is from May-June 2022. Okay, this question will be covering arithmetic sequences and quadratic sequences. Okay, so this is the question 2 from May-June 2022. Okay, you can see we have 2.1 and 2.2. On 2.1, you have 3 sub-questions, and on 2.2 you have 3 sub-questions. Okay, the total is 16 marks. Okay, you can see that. Let's get started on the next slides. Okay, let me get the question again. This is the question 2 from May-June 2022. Right, you can see. So question 2, 2.1, the first term of an arithmetic sequence is -1 and the seventh term is 35. Determine 2.1.1, determine the common difference of the sequence, 2 marks. Okay, 2.1 and 2.1.1. You are given the first term, which is t1, it is equal to -1. And you are given the seventh term, which is t7, it is equal to 35. You can see that. Okay, so 2.1.1, the question is to determine the common difference of the sequence. Okay, when you look at the formula, this is the formula that you can use to find any term of an arithmetic sequence, right? You are told that this is what an arithmetic sequence, and this is the formula to use to find any term of an arithmetic sequence. Okay, the question 2.1.1 is to find the common difference. The common difference is D. You have D there. So you can substitute your Tn with 35, which is the seventh term, and A, which is the first term. You know the first term is -1, you are told, and N is going to be substituted with 7 because 35 is the seventh term. When you substitute Tn with 35, your n will be equal to 7, right? And so you can solve for D, which is the common difference. Okay, let's do that. So Tn, you substitute Tn with 35, right? This is equal to, you have A, which is the first term. The first term is equal to -1. This is what you are told. The first term of an arithmetic sequence is -1. So your A is -1. Plus, in bracket, you have n minus 1. What is your n? Your n is 7, right? Because the position of 35 is 7. This is the seventh term, you can see, and the seventh term is 35. So your n is 7. You have 7 minus 1, right? You close your bracket times D. And so from here, you can solve for D. D is the common difference, right? And so you have this -1, you bring it to the left, it becomes 35 plus 1, which is equal to 36. And this is equal to, and then you have 7 minus 1, which is 6. 6 times D, which is 6D. Like this, okay? You can see. And so you need to solve for D. What is D? D is equal to, you divide by 6 on both sides. You divide by 6, you have D. You divide by 6, you have 6. 36 divided by 6 is 6. And so the common difference is 6. Okay, as simple as that. Now let's do question 2.1.2. This one. Let's do it here. 2.1.2. The question is, determine the number of terms in the sequence if the last term of the sequence is 473, right? You need to determine the number of terms in the sequence if the last term of the sequence is 473. The question is 3 marks. So you are told that the last term of the sequence is 473. Now the question is to determine the number of terms. Okay, if you can find the position of this last term, you are going to know how many terms you have in the sequence. You have to find the position of this number. In other words, you have to solve for n for this term. Okay, because you are told this is the last term of the sequence. Okay, so you are going to use this formula, the formula to find any term of an arithmetic sequence. This is the formula, and you are going to use it to find the position of this last term. Okay, so let's substitute Tn with 473, and this is equal to, what is your first term? You still have it, it's -1, plus, in bracket you have n minus 1 times d. Your d is 6. You have solved for d, right? And so now you can solve for n. N will tell you the position of this last term. And if you know the position of this last term, then you know the number of terms in the sequence. Okay, let's solve for n. So you have -1, you bring it to the left. Now you have 473 plus 1, which is 474, right? When you bring the -1 to the other side, so it becomes +1, and then you have this. And so this is equal to, you have 6 times n, which is 6n. You have 6 times -1, which is -6, right? And you bring this -6 to the left, it becomes +6. So you have 474 plus 6, which is equal to 480. And this is equal to 6n. I hope you can see that. And now you need to divide by 6 on both sides so that you can solve for n. So what is n equal to? When you divide by 6, you have n is equal to, you divide by 6, you have 80. So 480 divided by 6 is equal to 80. So the position of this term, 473, is 80. And from here you can conclude that you have, how many terms? You have 80 terms in the sequence. Okay, this is how you can solve this question. Okay, let's do the next question, which is 2.1.3. okay, let me make a line here, and I'm going to do my 2.1.3 here. Now the question is, determine the sum of the first 40 terms in this sequence. You need to determine the sum of the first 40 terms in the sequence. Okay, the question is 2 marks. Okay, the formula to determine the sum of the terms in an arithmetic sequence can be this one. You know this one, or you can use this one. So from here you can see we are going to use this formula, the one in black, because we want to find the sum of the first 40 terms. Okay, we're not going to use this one because we are not trying to find the sum to the last term, because L stands for the last term, and the last term is 473. So let's use this one, the one in black. So you are going to calculate what? S40, right? Because you are trying to find what? The sum of the first 40 terms. You are going to find S40 is equal to, what is your n? Your n is 40. You have 40 over 2, right? You have your square bracket, 2 times a. Your a is the first term. The first term is -1. So you have 2 times -1 plus, in bracket you have n minus 1. What is your n? Your n is 40. Because you are calculating the sum of the first 40 terms. So your n is 40. You have 40 minus 1. You close your bracket, times d. What is d? D is equal to 6. You close your square bracket. Okay, let me close this for now. Now you can calculate S40. Okay, now from here you need to plug this in your calculator, right? And so you can get the answer. Okay, I'm going to use my emulator. Okay, so this is my emulator. If you need it, please check the playlist, the one saying educational software. You're going to find a video which will show you how to download this software on your PC. Okay, so I'm going to use my emulator to calculate S40. So I've got 40 over 2. Open your bracket. You have 2 times -1, like this. So I'm going to plug everything the way it is. And then I have 40 minus 1, which is 39, but let me leave it like this, times 6, right? And so what is S40? S40 is 4,640, okay? 4,640. Okay, Let's move on to the next question. Let me do it on the next slide. Okay, now it's question 2.2. Let me get the question. So this is the question 2 from May, June 2022. Okay, this is the question. We are now solving question 2.2. We are done with question 2.1. Okay, question 2.2. So you have this quadratic number pattern, and 2.2.1, write down the fifth term of the number pattern. You need to write what? T5. Write down the fifth term of the number pattern. Okay, the question is 1 mark. Okay, 2.2.1, right? You need to write down the fifth term of the number pattern. You need to write what? T5. So this is the number pattern that you are given. You have 75, 53, 35, and 21. Okay, you can see it. So you have T1, T2, T3, T4, and you need to get what? T5, because the question is saying write down the fifth term of the number pattern. You need to write what? T5. You only have T1, T2, T3, and T4. Okay, you can get your first differences and your second differences, right? Because this is a quadratic number pattern. You know that you have the first differences and the second differences. Okay, let's get the differences. So what is the difference between 75 and 53? What is the difference here? So you have 53 minus 75. This is equal to negative 22. When you take 53 minus 75. So the difference between 75 and 53 is negative 22. What is the difference between 53 and 35? The difference here is when you take 35 minus 53, you always take the next term minus the previous term to get the difference between the terms. Okay, so between 53 and 35, what is the difference? Take 35 minus 53. The difference is negative 18. And you do the same here. What is the difference between 35 and 21? The difference is negative 14. I hope you can see that. Just take the next term minus the previous term. This is the difference between the two terms. So the difference between 35 and 21, the difference is negative 14. Okay, so these are the first differences. Let's get the second differences. Okay, what is the difference between negative 22 and negative 18? You take the next term, which is negative 18, minus 22. And the difference here is 4. I hope you can see that. Negative 18 minus 22. The difference is 4. You do the same here. Negative 14 minus 18. The difference is 4. Okay? So between negative 18 and negative 14, the difference is 4. Between negative 22 and negative 18, the difference is 4. Okay? So now you can see this is the second difference, right? You can see. So the second difference of a quadratic number pattern is constant. So it means that this will keep on being 4, 4, 4, 4. Okay, so you can continue in this fashion to get the next term of these first differences. Okay, so you have the difference here is 4, right? There, it will be 4 because this is the second difference, which is constant. It is the same value. It will continue to be 4, 4, 4, right? So what is the next term here of the first differences? What is the next term? So you have negative 14 plus 4. This is going to be equal to negative 10, right? Negative 14 plus 4, it's going to be equal to negative 10, right? You continue in that fashion, 4, 4, 4, 4, 4, right? Because this is constant. So now you have 21 minus 10, right? 21 minus 10. What is the next term? Which is T5. This is going to be equal to 11. You can see between 21 and 11, the difference is negative 10, right? So you can see from here, T5 is 11, and this carries on. It continues, right? So your T5 is equal to 11. Now let's do the next question, which is 2.2.2. Determine the nth term of the number pattern. You need to determine what? The general term. When they say determine the nth term of the number pattern, they are asking you to determine the general term. Okay? let me make a line here and let me do 2.2.2 here, right? So you need to determine the general term. Okay, so you are going to determine the general term in this form. Tn is equal to an squared plus bn plus c, right? And the number pattern is what? Is a quadratic number pattern. You know that. So it's going to be in this form. This is why I have Tn is equal to an squared plus bn plus c. Okay, so let's get the number pattern down. This is the number pattern that you have. You have it here with all the first differences and the second difference, right? So let's get the number pattern down as we have it in the previous question. This is it. You can see 75, 53, 35, 21 as it is in the previous question. You can see, and you have your first differences and the second difference is 4, you can see. Okay, so this is the number pattern. From here, you need to determine the nth term or the general term. This is what you are given. You can see 75, 53, 35, 21. This is what we have here. So after getting your first differences and your second difference, now you can get your general term in this form. That's how you can solve this question. Determine the nth term of the number pattern. So to determine the nth term of the number pattern, you need to get your A, B, and C. To get your A, B, and C, you are going to use these terms in the diagonal. Can you see the terms in the diagonal? You have 75, negative 22, and 4. Use these terms in the diagonal to determine your A, B, and C. So these are the terms you are going to use: 75, negative 22, and 4. So this is how you are going to determine your A, B, and C. This 4 is equal to 2A. So you have 2A is equal to 4. And this negative 22 is equal to 3A plus B. So you have 3A plus B is equal to negative 22. Okay. And this 75 is equal to A plus B plus C. Okay. So you have A plus B plus C is equal to 75. Right? Let me close this. So from here, you know that 2A is equal to 4. And what is A? Divide by 2 on both sides to get your A. A is equal to 2. Okay. Now you have your A. Now use this one to get your B. You have your A. So you have 3A plus B is equal to negative 22. You can see. Now you have 3A. So it's 3 times A. A is 2. Right? Plus B is equal to negative 22. So this is 6. 3 times 2 is 6. You take your 6 to the right side, it becomes negative 6. So B is equal to, so it's negative 22 minus 6, which is negative 28. And you carry on to this one to determine your C. You have A plus B plus C is equal to 75. You can see. So what is your A? Your A is 2. And what is your B? Your B is negative 28. So negative 28 plus C, right, is equal to 75. You can see that. Okay. So what is your C now? You can find your C. C is equal to, you have this, which is 2 minus 28. This is equal to minus 26. You bring it to the right side, it becomes plus 26. So you have 75 plus 26. This is equal to 101. Okay. So Tn, the nth term, is equal to an squared. What is A? A is 2. So you have 2n squared, right? Plus Bn. What is B? B is negative 28. So you have negative 28n, right? Plus C. What is C? C is equal to 101. So you have plus 101. Okay, this is how you solve 2.2.2, the nth term of the number pattern. Okay, now let's do the last question, which is 2.2.3 on the next slide. Okay, now it's 2.2.3. Let me get the question. Question 2 from May, June 2022. Okay. Now it's 2.2.3. Determine the maximum value of the following number pattern. Okay, this is the number pattern. You have to determine the maximum value in the number pattern. You can see you have negative 15, negative 53 over 5, negative 7, negative 21 over 5, and so on. So there is a maximum value in this number pattern. You need to determine that maximum value. Okay, so this question is under quadratic number pattern. So it's under 2.2. So obviously, this is also a quadratic number pattern, but let's see if it is also a quadratic number pattern. Okay, we are going to determine the maximum value of this number pattern. Okay, and this question is 4 marks. So before we can determine the maximum value of this number pattern, let's get the general term of this number pattern. Okay, the general term of this number pattern will be in this form. Okay, I am sure that this is a quadratic number pattern. Okay, we are going to see. Okay, so this is the pattern that you are given. You are given negative 15, and you have negative 53 over 5, and you have negative 7, and you have negative 21 over 5, you can see, and so on, you can see. Okay, we need to get the general term first, and after getting the general term, we can now determine the maximum value of the number pattern. Okay, let me close this. We are going to determine the maximum value of this number pattern. Okay, just as we did it in the previous question, we need to get what? The general term. You have to get your first differences and your second differences. So what is the difference here? When you take negative 53 over 5 minus 15, you're going to get this. You can do that with your calculator. And what is the difference between the two terms? When you take negative 7 minus 53 over 5, so you take the next term minus the previous term, you have negative 7, which is the next term, minus the previous term, which is negative 53 over 5, right? Negative 7 minus 53 over 5. This is going to be equal to 18 over 5. You can check with your calculator. And what is the difference here? The difference here is going to be between negative 7 and negative 21 over 5. It's going to be 14 over 5. And so these are our first differences. Let's get the second difference. So what is the difference between 22 over 5 and 18 over 5? Take the next term minus the previous term. So you have 18 over 5 minus 22 over 5. What is the difference? The difference is going to be negative 4 over 5. You do the same here. 14 over 5 minus 18 over 5. What is the difference? The difference is going to be negative 4 over 5. You can see this is what? This is a constant difference. You can see negative 4 over 5, negative 4 over 5. So it's going to be negative 4 over 5, negative 4 over 5, and so on, right? The second difference is constant. Okay, so you can see, since the second difference is constant, you can conclude that this is a quadratic number pattern because the second difference is constant. Okay, now use the numbers in the diagonal. These numbers in the diagonal. This one, negative 15, 22 over 5, and negative 4 over 5. Use them to get your A, B, and C. So you know this is equal to 2A. So you have 2A is equal to this, right? And what is your A when you divide by 2 on both sides? A is equal to negative 2 over 5. You can check it, right? And this is equal to 3A plus B, right? 3A plus B is equal to 22 over 5. And you have 3 times A, your A is this, right? Plus B is equal to 22 over 5. And what is your B? When you take this to the right side, B is equal to 28 over 5. You can check it. And you carry on. Now you have this, which is equal to A plus B plus C. So you have A plus B plus C is equal to negative 15. Okay, so you are using the numbers in the diagonal to get your A, B, and C. These numbers to solve for your A, B, and C. Now, A plus B plus C is equal to this. what is your A? Your A is this one, right? And plus B, what is B? B is equal to this. You can see it. Plus C, we are going to solve for C. This is equal to negative 15, right? And C is equal to, when you take this one, you bring it to the other side, right? So you have negative 2 over 5 plus 28 over 5. This is equal to 26 over 5. You take 26 over 5 to the other side, it becomes negative 26 over 5 minus 15, you get negative 101 over 5. And let me make a line here. And let me continue here. Now you have your A, B, and C. So you can get your general term in this form. Okay, so Tn is equal to an squared. What is your A? Your A is negative 2 over 5. So you have negative 2 over 5 n squared plus your B is this one, right? You have Bn, and plus C. Your C is negative 101 over 5. There's your C. So this is your general term. So after getting your nth term or your general term of the quadratic number pattern, now you can determine the maximum value in this quadratic number pattern. Okay, remember this. When you look at this, this is actually a parabola. This is an equation of a parabola, right? So remember, from a parabola, if we want to determine the minimum value or the maximum value, this is what you do. You take the derivative of this. You make the derivative equal to 0 and you solve for your x. In this case, we have n. So you solve for your n, right? You take the derivative, you make the derivative equal to 0 and you solve for your x or your n. In this case, we have n. That is one way to solve this question if you want to find the maximum or the minimum value. There is another way. You can use this formula from the quadratic formula. You have n, so I'm going to call it n maximum, like this, n max. It's equal to negative b over 2a. So this part, negative b over 2a, is obtained from the quadratic formula. So you are going to use this n maximum, you plug it inside the original equation, and then you have your maximum value in this quadratic number pattern. Okay, let's get the n value, which is going to give us the maximum value. This is equal to, what is your b? Your b is this one, 28 over 5. Your c is negative 101 over 5. And your a is negative 2 over 5. So you have negative, what is b? This one, 28 over 5 over 2a. 2 times a, what is your a? Your a is this one. Okay, and this is equal to, you can use your calculator. When you plug this in your calculator, you are going to get this equal to 7. You can check it. You can pause the video and check it. Okay, so this is the value of n that is going to give us a maximum value in the quadratic number pattern. So after finding n, you are going to take that value and plug it inside there, right? So T maximum is equal to, you have negative 2 over 5 times n squared. What is your n? Your n is 7. So you plug 7 wherever you have n, right? You have n there. Remember, it's square, plus 28 over 5 times n. Your n is 7 minus 101 over 5, right? And so what is T maximum? You can use your calculator and get the answer. So when you use your calculator, you plug this in your calculator, the answer will be negative 3 over 5. Okay, so this is the maximum value in this quadratic number pattern. So this is the highest value that you can find in the quadratic number pattern. No matter how you continue this quadratic number pattern, this is going to be the maximum value. You can check it. You can change it to decimal so that you can see. And you can also change this to decimal. You also change this to decimal so that you can see. Remember, for example, negative 15 is smaller or less than negative 7. You have to see that on the number line. Remember that. So convert this to decimal and convert this to decimal and convert this to decimal, you are going to see that this is the highest value. No matter how you continue with this quadratic number pattern, this is going to be the maximum value. Okay, so this is how you solve for the maximum value or the minimum value. It depends on the question. Sometimes they can ask you to find the minimum value or they can ask you to find the maximum value. The procedure will be the same, whether you are trying to find the maximum or the minimum value, right? So you get your n first by using this formula or using derivative. After getting your n, you plug it inside the original equation to get your maximum value. Okay, you can see this is a parabola. This is actually a parabola which is concave down because of the negative day. The parabola is concave down like this. This is why you are finding what the maximum value. If this parabola was concave up, if it was positive day, it was going to be concave up, and in that case you are going to find what the minimum value. So the process to use will be the same. Okay, I have said enough and we are done with question 2 from May-June 2022. So I hope the video is helpful. If you find value in the video, please show that with your likes. Comment in the comment section. Remember to subscribe and activate the notification bell so that you can be notified whenever new videos are posted. Until next time, I will talk to you soon.